All right, continuing to solve trig equations, guys. We've already been doing this for a while now. This is a review because we just come back from Turkey Day. Gobble, gobble. So hopefully your tummies are full, and hopefully you guys are ready for the good fight. All right, so all of this should not be a review because we've been doing this for a while now. Here's my equation if you're in degrees for arc sine, if you're in radians. Here's the angle. Here's the formula for arc cosine. Chav, how come I don't have two equations like I do for arc sine? Well, yeah, you do. That's where the plus minus comes in. The plus is one of them, the minus is another. Same thing for if you're in radians, and here's arc tan. Chav, where are the formulas for arc secant, arc sine, and arc secant, arc cosecant, and arc cotangent? Well, just turn them into, if you have a secant, turn that into a cosine, and then do the inverse. If you have did I say secant? If you have a cosecant, turn that into a sine, and then do the inverse of that. So yeah, there it is. So, you ready, Miss Salazar? Focus, Miss, focus. All right, so here we go. Look at this page right here. It says, let's chat about where these formulas were derived by looking at a perfect coordinate. Okay, so go ahead and let's draw a unit circle. And I'm going to go at 30 degrees. And I'm going to go to negative 30 degrees. Bless you. At both of those coordinates, the x coordinate is square root of 3 over 2, comma half. And square root of 3 over 2, comma negative half. And I want you guys to notice, so if I were to write cosine of 30, let me keep with the color coordinate. So I'm going to write it, continue in black. So if I were to write cosine of 30 degrees, you would tell me square root of 3 over 2. If you were to tell me cosine of negative 30 degrees, you would tell me square root of 3 over 2. Now, on my calculator, if I were to type arc cosine, or inverse cosine, of square root of 3 over 2, no matter how hard I try, the calculator will always spit out the 30-degree answer. But you and I know that negative 30 degrees also works. So that's why we put a plus minus. Because we know that the negative 30 degrees also works for that angle. At that angle, cosine of negative 30 is square root of 3 over 2. Does that make sense to everyone? Okay, so now I'm going to change my colors and I'm going to go to a blue one. So now I'm going to focus on still the 30-degree one. So notice at 30 degrees here, that is still square root of 3 over 2, comma half. And I'm going to say that this reference, and I know it's not very good there, but the reference angle is 30, negative square root of 3 over 2, comma half. So I know this. I know that sine of 30 degrees is a half, and I know that sine of 150 degrees is a half. But no matter how many times I type into my calculator, arc sine, that's an N, I don't know why it came out like that. Arc sine of a half, no matter how many times I type it out, my calculator will always spit out 30 degrees. But I know that 150 is an answer. So how do I get the 150? Well, you get the 150 by just going 180 minus arc sine of a half, bless you squared, and that will give me that 150. Chub, but why? Because notice, guys, that this is actually my reference angle in quadrant 2. And 180 minus that 30 will give me that 150, sorry. Does that make sense, guys? Or does that not make sense? Okay, that's how we know that these two equations work. That's why we have these two equations. That's if you don't want to think. If you want to just use your logic a little bit, then you can always just find the reference angle by keeping it positive and then finding what quadrant you're in and then adjusting your answer. All right, and then last but not least, arctan. I don't think we have to worry too much about arctan, guys. So watch, we'll do this one really quick. So at 45 degrees, square root of 2 over 2, square root of 2 over 2. So if I told you tan of what angle equals 1, you would tell me arctan of 1, you would say 45 degrees. And that is true. And then I want you guys to recognize that if I go in quadrant 3 here, negative square root of 2 over 2, negative square root of 2 over 2. That is also 1, right? Negative divided by negative is a positive. But that's not a big deal. This is a linear pair, so I can just add 180 to it. So 45 plus 180, what's that? 18, 19, 20, 21, 225. And sure enough, tan of 225 is 1. So check it out. Sorry guys, I should have had my calculator open already. Come on, buddy. So here it is. There might be some junk already in there. Nope. All right, I'm in radian mode. I'm going to switch my mode to degree real quick. Come on, buddy, degree. Degree. All right, second quit. And notice tan of 45 is 1, and then tan of 225 is also 1. Cool. So that's where tan just has one equation. It's either just add 180 to it. See? I shouldn't have been. Or if you're in degree mode, add 180. If you're in radian mode, add pi. That's where all, see, there it is. That's where all three equations come from. Do we have any questions on that, guys? You guys look like you guys are having a blast. All right, here we go. So now let's go ahead and solve this. So look how simple this is. It's actually really simple, guys. It's not a perfect coordinate. It says algebraically. So this is what I want to see. I'm trying to solve for x. I want all the answers between 0 and 4 pi. So the first thing I'm going to do, this is just like algebra, guys. Divide by 10. So I guess let me write the expression down first. 10 sine x minus 0.2 equals negative 3. Divide by 10. So then I'm going to write sine x minus 0.2 equals negative 3 over 10. If you want to write negative 0.3, that's fine. Are y'all all right? Cool. Next, I want to get rid of that sign. So to get rid of that sign there, I have to do the arc sign, the inverse. X minus 0.2 equals arc sine of negative 3 over 10. We're in radians, plus 2 pi n. I'm going to call this x1. And then I'm going to do another equation. I'm going to call it x2. I'm going to do it in blue. I'm going to write x2 minus 0.2 equals pi minus arc sine of negative 3 over 10 plus 2 pi n. Is everyone okay with why I wrote the one in blue? Okay, remember, in case you're wondering, remember guys, just look it up right here. Whenever you're doing for arc sine, you have this equation and you have this equation. I'm doing the pi minus arc sine part. And then whatever you have on the left-hand side, whatever the argument was, well, that's what you have, right? So there it is. So I'm doing that. So here we go. I'm going to go back to the one in red. If you have colored pencils, it is a good place to do your colored pencils. Put the 0.2 right here in the front so you don't mess up. x1 equals 0.2 plus arc sine of negative 3 over 10 plus 2 pi n. In a little bit, we'll see what that is. I'm going to go back to the one in blue. x2 equals 0.2 plus pi minus arc sine of negative 3 over 10 plus 2 pi n. And I'll wait for you guys to catch up. We should open up like a cafe in the cafeteria or something, where we can always get like cappuccinos and, you know, frappes, sell them for like $1 or something, you know? That would be really cool. I'd be down there all the time. All right, take your calculator. Here we go. Make sure that you're in radian mode. So let me click on mode on mine. If you have one of the older calculators, it's not going to tell you. So now it says radian, okay? And I'm going to type 0.2 plus arc sine of negative 3 over 10. Type just this part right here, guys. Type this part. 0.2 plus arc sine of negative 3 over 10. 0.2 plus arc sine of negative 3 over 10. And I get negative 0.10469. x1 equals negative 0.10469. 10469 plus 2 pi n. I'm going to go to x2, and I'm going to see what this number is. 0.2 plus pi minus arc sine. All right, let's see. 0.2 plus pi minus arc sine of negative 3 over 10. 3.64628, 3.646, 3.64628 plus 2 pi n. The more digits, the better. All right, here are my answers, guys. X equals, my first answer, that one, 3.646285. Let me write it more to the left because there's 4 numbers probably. X equals 3.646285, comma. The next one's going to come from x1. Add 2 pi to that. So I go to my calculator, and I'm going to scroll up, and I'm going to push enter, plus 2 pi. And then I push enter again. 6.17849. 6.17849, comma. The next one is going to come from the 3.64 plus 2 pi. Isn't this super exciting? Do you feel the stress coming off? I feel like this is super, what is it called? Mental health? 9.92947. 9.92947. And then finally, the last one, take the 6.17 and add 2 pi to it. Plus 2 pi. 12.46167. 12.46167. Was that awesome or what, guys? You guys never go to a coffee shop with a math book and just like open it and do some random problem just like for the heck? Math is supposed to be the easiest subject from all subjects, right? No, it really is, because it's just logic, guys. It's not like in literature where the author writes that the curtains are blue, and then your professor or teacher is like, "Why did the author mention that the curtains are blue?" And then you're supposed to respond, "It's like it's symbolism. It's supposed to mean that, like whatever it means. I don't know." But what if the author really just meant like the curtains are blue? Like I just wanted you guys to see that the curtains were blue. All right. Now, big asterisk, put an asterisk on this. I am going to ask you this question on the exam. We don't have enough time to give 2 exams, so I'm just going to give you this question on the semester exam. If it does not say the word algebraically, you don't have to do any of this. If it does not say the word algebraically, you can just type this into y1 and type this into y2 and then see where they intersect, like this. So look, I'm going to take my calculator, I'm going to go to y equals, and on y1 I'm going to type in what I have on the left hand side. 10 sine x minus, I already forgot, what was it? 0.2. X minus 0.2, close. And on y2, we want it to be negative 3, right? All right, so check it out. Then I'm going to click on window, and I'm going to go from 0 to 4 pi, because that's where they want me to look. And then you don't really care about like to see the whole wave because you just care about where it intersects negative 3 there. So I'm going to go negative 10 to 5. And I'm going to push graph. And there's my wave. And there it is. So I better see 1, 2, 3, 4. These are my 4 answers. So let's see. I'm going to tell the calculator. Second, calculate number 5. Enter, enter. And then when you get that little guess thing, go to the one you want. I'm going to push enter on this one. And I got 3.6462. Is that an answer that I have? Perfect. Let's go to the next one. Second, calculate number 5. enter, enter. And I'm going to go to the second one over here. Rather than letting me, there we go. Enter. 6.17849, is that another one? Do I have that or no? 6.17849, yeah, there it is. And we're going to do the same thing, guys. Second, calculate number 5. Enter, enter. And then I'm going to scroll to this third one right here. And there it is, 9.92947. Second, calculate number 5. Enter, enter. 12.46167. And there it is. We got them all. Cool or not cool? Cool, right? Okay, look at this one. This one doesn't say that we have to do it algebraically. So if you wanted to, you could just do them by calculator, guys. But notice that it says in degrees. So someone out there, if you guys want to try it out, see if you guys can do that one in degrees. I'm just going to put my calculator in degrees and do it algebraically, guys. So let's see, mode, degree. All right, here we go. Someone try it just with graphing. Excuse me. You're going to have to make it pretty big. So here we go. So I'm going to write 4 tan x equals negative 5. Divide by 4, both sides. Divide by 4, divide by 4. So now write tan x equals negative 5/4. Now if I want to get x by itself, you have to do the inverse. Yay or nay? X equals arctan or inverse tan of negative 5/4 plus 180n, because we're in degree mode. And I'll just take my calculator. Let me give my answers now. So let's see. And then someone do it graphically, see if it matches. I'm going to go second arctan, negative 5/4. I'm going to push enter. I get negative 51.340. That's not an answer because it needs to be between, it wants the first 3 positive. So I'm going to add 180. So there it is. That's one of them. 128.6598. 128.6598. Put a little degree symbol. What's another? Push enter on this. And look, it gives you the next one. 308.6598. 308.6598. Push enter one more time. And it'll give you my third one. 488.6598. How do you feel? Did anyone do it graphically? Oh man. All right, here's how you would have done it if you would have done it graphically. Put 4 tan x on y1, put negative 5 on y2. So look, y equals, push clear to get rid of that. And I already forgot. What did I say? 4 tan x. 4 tan x. And what did I say on y2? Negative 5. All right. On window, since I already know my answers, look, they're between 128 and 488. So I'm going to go between 0 and 500. I'm going to go 0 all the way to 500. And X scale doesn't matter, but I don't want to see a whole bunch of little sticks, so I'm going to put 100 there. And then Y min, well, I only care about, let's see, where it's negative 5. So I'm going to go negative 10 to 0. So I'm going to be looking at the middle there. Push graph. So check it out, guys. It's these 3 answers right there. So I'm going to go second, calculate, number 5. First curve, yes. Second curve, yes. Guess. I'm just going to move to this one right here. Hover over it and then push enter. Look at that. 128.6598. Cool, right? I'm doing the same thing again, guys. Second, calculate, number 5. Enter, enter. And I'm just going to hover over the second one that I want. And I'm going to push enter. So, bam. 308.6598. See? Let's do it one more time. Second, calculate, number 5. Enter, enter. And then hover over it. And bam. Look at that. See? Cool, right? Or is this not cool? Are you not entertained? I'm super entertained. I'd pay good money for this. All right. Is this the last one? No, we still got plenty. Don't worry. This one's not that bad. We're almost done, guys. We're almost done. We got 2 left. This is factorable. This, remember, you had something like this in algebra, guys. In algebra 2, x squared minus x minus 2 equals 0. That's what you had in algebra 2. This is similar. Similar to that. When you had that in algebra 2, what would you do? You would factor it. Either that or you'd use the quadratic formula. But this one you don't need to use quadratic formula because it's factorable. So let's see. X minus 2x plus 1 equals 0. See? X times x is x squared. Negative 2 plus 1 is negative x. Negative 2 times the positive 1 is negative 2. Perfect. So if you were in algebra 2, you would say, well, x has to equal 2. 2 minus 2 is 0, and anything times 0 is 0. Or x has to equal negative 1. Negative 1 plus 1 is 0, and anything times 0 is 0. So these are my 2 solutions. If this were an algebra class, you'd be done. This is not what I have. So because it's similar, that means this expression, you can write it like this. Sine x minus 2, sine x plus 1. See? And then you just go, well, that means that sine x has to equal 2. That will never happen. Sine x has to be between negative 1 and 1. Or sine x plus 1 has to equal 0. So that means sine x equals negative 1. Then I take my calculator, or just from knowing the unit circle, sine x is the y value. The y value is negative 1 right there at that coordinate. So either the answer is 270, or if I go clockwise, negative 90. Can I use 270 as an answer choice? Look at your domain. No. Can I use negative 90 as an answer choice? Yes. So my only answer is negative 90 degrees. Oh, that's probably one of my best smileys ever. I am really happy right now. How do you guys feel? Don't worry, guys. By Wednesday, we're going to be doing application problems, so you're going to see how this is useful. If you know an engineer, talk to the engineers, and you can see that this is so useful in a lot of stuff. The AC circuits are done with this. Okay, yeah. If you want to know about them or not. Okay. Let's say for a job interview, they ask you to solve the following problem. It is not unheard of. It is not unheard of for engineers to be given questions like this. I remember when I engineered, one of my questions was, it was like a logic circuit, and I needed a certain desired, like we needed to do like a certain result. So you had to do a Carnot map. Does anyone know what the Carnot map is? Okay, don't worry about it. Have you ever seen logic gates? Do you guys know what I'm talking about? Have you ever seen something like this? That's an AND gate. Have you ever seen something like this? That's an OR gate. No? Okay, then don't worry about it. Don't worry about it. Some of you will, if you're in the engineering field, you'll know about it. If not, you won't know about it. Okay, it's really cool stuff. It's really cool stuff, I guarantee you. All right, so look at this one, guys. I need everyone's attention for this one because this one's not factorable. So I have a function. Let's go back to red because I like the color red. I have this function, 4 sine squared x minus 2 sine x minus 3 equals 0. So this is similar, to 4x squared minus 2x minus 3 equals 0. When you had that question, when you were in algebra with Ms. Torres, how would you solve that question? You can't, it's not factorable. If you try to do the AC method, that gets you negative 12x squared. So two numbers that you multiply to give you negative 12x squared to add up to negative 2. So let's see, there is negative 12x and 6x. Nope, that doesn't add up to negative 2. There's 4x and negative 3x. That adds up to negative 1. Did I say 12 and 6? Why did I do that? That's not even 12x and 1x. Nope. 6x and 2x. Nope. Nothing works. Yeah, sorry about that first one. That was dumb. That one, 12x times 6. Pretend I'll leave the video unedited. That doesn't even make sense. But it's not factorable. You can't factor this out. So how would you solve it in algebra? Yeah, perfect. Quadratic formula. Do you remember the quadratic formula? Oh. Are you guys trying to remember the song?
Yeah, I don't.
Yeah, my teacher was weird. He taught me there was a negative boy who was undecided about going to a radical party, and he was a square boy, B squared. Yeah, okay, don't worry about that. Yeah. I don't remember actually. I do, but it's not. He was weird, and it's not PG-13. So, yeah, I should have never mentioned that. Yeah, just do the song. Negative boy plus or minus square root b squared minus 4ac all over 2a, or I don't know, something like that. Go to YouTube and put like the square root song or something, you know? The square root song. What is it called? Quadratic song. All right, here we go. You can only use this if you have lists, right? So a is 4, b is negative 2, and c is negative 3. Now, first period had a lot of confusion because they did not use parentheses. So if you don't want to use parentheses, then use the alpha feature. I'll show you what I'm talking about. X equals, opposite of negative 2 is 2, plus minus square root, negative 2 squared minus 4 times negative 3. All this is over 2 times 4. See what that is. 2 plus minus square root. 2 squared is 4 plus, because negative times a negative. 4 times 4 is 16. 16 times 3 is 16. 32, 42, 48. All over 8. So x equals 2 plus minus square root 48, 49, 51, 52 over 8. Okay, let's get our answers. Semicolon. 1x is, so let's see what that is. Okay. Here we go. 1x is, I take my calculator, and I'm going to clear this. I push alpha, y equals, enter. And then you don't have to think. You just put whatever's in the top, whatever's in the bottom. 2 plus square root, I already forgot. What did I have? 52? 52 all over 8. Enter. 1.151. 1.151. The other one, change the plus to a minus. Scroll up, and then just, left, up, left, minus. Negative 0.651387. Negative 0.651387. 138781. The more digits, the better, guys. Are you okay? We haven't even solved our problem yet. Okay. Don't worry, we're going to go slow. That's if we had this. We don't have that. We have this guy. But relax. The only thing that changes, instead of x, you're going to say sine x. So you're going to write sine x equals 1.151. That's not possible. So that we don't have to worry about that. But this one is sine x equals negative 0.65138781. And then to get x by itself, you're going to do inverse sine. So x equals arc sine of negative 0.65138781. Just put whatever number you have in the calculator plus 2 pi n. That's x1. x2, pi minus, don't forget this one, arc sine of negative 0.65138781 plus 2 pi n. Here are my answers. Y'all ready? Let's type that in. Arc sine, second arc sine, negative, and I already forgot, 0.65. Oh, I have it up here. Do I have it up here? Yeah, there it is. That guy. Enter. Delete. Clear. Second arc sine. Let's see if we can do this. There we go. Enter. I'm still in degree mode. Mode. Radian. Finally, guys. Here we go. Enter. Negative 0.709. I'll just put an arrow here. X equals negative 0.709 plus 2 pi n. That's x1. And let's see what x2 is. Pi minus n. Second pi minus this guy. 3.851. We're almost done, guys. 3.851. Okay, here are my answers. My final answers. I want them all between 0 and 2 pi. So one answer is 3.851. And the other answer is take the 0.709 and add 2 pi. 0.709, so scroll up. Plus 2 pi. Enter. 5.57377. 5.57377. Let's check if we're correct, guys, real quick. How do we check it? You can just type this into y1. You don't have to type the 0 into y2 unless you really want to. Here's how you do it. Let me clear y2 though. All right, here's how you do it. I'm going to push 4, open parenthesis, put sine x, close, put a square on it. And I already forgot the equation. 4 sine squared x minus 2 sine x. So minus 2 sine x, close, minus 3. Minus 3. And then on y2, don't type anything in. And then I'm just going to go to window. I'm going to go from 0 to 2 pi. 2 pi. And you just care about where you cross the x-axis. So I'm going to go from negative 4 to 4. Negative 4 to 4. Oops, I put x scale negative 4. 1, that's fine. Negative 4 to 4. Graph. Okay, it's these two right here, guys. How do I tell the calculator? Look, you just let the calculator do all the heavy work. These are called zeros because you cross the x-axis. Second, calculate a 0, number 2. Don't worry, we're almost done. And then it says left bound, so it's like, where do you want me to look? Between here, enter. Right bound, and just go a little bit to the right of that, enter. Guess, nah. Boom, 3.851. We got it right. Second, calculate. 0 again, number 2. And I want you to look between, it says left bound, so I'm going to go like right there. Enter. And then move a little more to the right, and then push enter again. Guess, and then bam, 5.573. See? We're done, guys. We're good. So we got them right. What do you guys think? Pretty cool? All right, we just have 5 questions to do, so don't worry. I have it right here. It's a little handout. Most have been able to get it done pretty quickly. And if you have questions, let me know, and we'll do them together.